In this video we'll talk about cube roots, and if you haven't already, check out the videos on square roots and prime factorization, as both are very important and critical to understanding this concept. So a cube root is basically, we're looking at, like a square root is, we're figuring out what number times itself would make a particular number. In this case we're looking at the square root of 81. That's 9. We know that to be true. However, if we look at a cube root, let's take 125, or no, let's take 8, for example. Just 8. Well, I have to ask myself, okay, what number times itself 3 times makes 8? So, in essence, I'm taking something times something times something to make 8. And that question is a little more difficult. Now, since 8 is a fairly simple number, we can deduce that's 2, but we do point this out for notation. It's kind of like a square root, except it has a little 3 hiding up there. And we'll talk about some strategies to figure out how to find these cube roots here in a second. So let's look at a cube. This would be kind of what a cube root would be useful for in context. So a cube, even if it doesn't look it in my drawing, has all of its sides the same. Let's call them S. So it has a height of S, it has a base of S, and it has a depth of S. All of these sides are the same, even if it doesn't look it in my drawing. We know that the volume of this cube is S times S times S, or S to the third power. And we could also say that the cube root of the volume is equal to S. They would be an inverse operation. And this can be very useful, because sometimes I'll know the volume of the cube and I'll want to know the dimensions. So if I knew the volume was 8, I could deduce all the sides must be 2. So I could take the cube root of 8, and that would be 2. There's my volume, and there's my side length. And this would just be kind of in context an application for cube roots. So let's talk about it. Let's say we wanted to evaluate the cube root of 216. Now, off the top of my head, I don't exactly know what that is. So what I can do is I can make a factor tree for 216. And I'm thinking, okay, I can divide it by 2, just to make my life a little easier. So this would become 108. And the 2 is prime, so we're good there. Okay, I'm going to break 108 up. Again, I can divide that by 2, and then I should get 54. And then I can divide it by 2 again. And then I should get 27. Now, 27, I can't divide by 2 anymore, but I can divide by 3. I'm just kind of going through what I see here. And then it's 3 and then 9. The 3 is prime, the 9 is not. I can do 3 and then 3. So then I can rewrite this as 2 to the third power times 3 to the third power, which I could potentially, since both these powers are to the third power, I can rewrite this as 2 times 3 in parentheses to the third power, which is 6 to the third power. Which means that if I take a cube root of 6 to the third power, the 3's are going to cancel, leaving me just 6. So it's kind of a way to think about it. You could make a factor tree, and you might not even have to finish it. If you would have started with a 6 here, you probably would have got 6 and then 36, where I had the 108. And then you realize you have 3 of the same, you have a perfect cube. Now, not all numbers are perfect cubes, just like all numbers aren't perfect squares. There might not be a nice one, and we'll talk about how to do that in the next lesson. But for now, we're just looking at perfect cubes and this relationship between cube root and cubing.